Hello, children. I hope you have understood chapter number 1, Rational Numbers, well. You must have completed also the homework questions assigned to you in the previous lectures. Now, at the end of this lecture number 4, I will discuss the homework solutions of the previous lecture also. Coming to lecture number 4 of Mathematics Class 8, chapter number 6, Squares and Square Roots. Dear children, as the name indicates, squares, and in your previous classes, you must have learned the area of square that is equal to side into side, that is side square. So, we can say that square of a number is the product of a number by itself. For example, if I take number 1, its square will be 1 into 1, that is 1. 2, the square of 2 is 2 into 2, that is 4. Another number can be taken as 3, that square of that number 3 is 3 into 3, that is 9. Similarly, you can find out the square of all the numbers. So what is the square? What is the square of a number? It is the product of a number by itself. If I am multiplying the same number by itself, then I will be getting the square of that particular number. Simple as this. Now, coming to square numbers. What do you mean by square numbers? Any natural number p which can be represented as y square, where y is a natural number, then p is called square number. Now, what does it mean? I told you in the previous slide that if I am taking the square of 2, that will be 4. So here 2 is your natural number and 4 is your square number. Likewise, 2 square is equal to 4, 3 square is equal to 9, or we can take it as like this also. 4 is equal to 2 square, 9 is equal to 3 square, 16 is equal to 4 square. It is one and the same thing. So here 2, 3 and 4 are the natural numbers and 4, 9, 16 are the respective square numbers. So such types of numbers are known as square numbers or perfect squares. I am repeating it. It means square numbers. What are square numbers? If I am taking any natural number and I am squaring that natural number, the result so obtained will be your square number. For example, 4 is equal to 2 square or 2 square is equal to 4. It is one and the same thing. 9 is equal to 3 square. 16 is equal to 4 square. So here 2, 3, 4 are the natural numbers and 4, 9 and 16 are the respective square numbers. So such types of numbers are known as square numbers or perfect squares. Now, the question comes in your mind, how we will come to know that whether a given number is a perfect square or not, or it is a square number or not. Now, to find out whether the given number is a perfect square or not, we need to do the prime factorization of that particular number. For example, I have taken two examples here. Let us take 16. Now, the prime factorization of 16, after the prime factorization of 16, the prime factors of 16 will be 2 into 2 into 2 into 2. It means 16 can be expressed as the product of equal prime factors. Here, 2 is repeating 4 times. So, 16 can be expressed as the product of equal prime factors. Equal 2 into 2, that is making one pair, 2 into 2, another 2 into 2, that is making another pair. So, as the definition also indicates, a perfect square can also always be expressed as the product of pairs of equal prime factors. The numbers should be present in pairs and it should be a prime factorization and it should be equal. So, three things should be there. It should be prime factors. It should be present in pairs, equal pairs. That's it. It should be the product of the numbers. Now, taking another example, prime factorization of 48. Here, if I do the prime factorization of 48, the factors will be 2 into 2 into 2 into 2 into 3. Now, here in this case, 2 into 2, this is a complete pair. Again 2 into 2, this is again a complete pair, but 3 is left unpaired. So we can say that 48 is not a perfect square. It means 48 cannot be expressed as the product of equal prime factors. So 48 is not a perfect square. So to find out whether a given number is a perfect square or not, we need to do the prime factorization of the number. If that particular number can be expressed as the product of pairs of equal prime factors, then we can easily say that that particular number is a perfect square. Now, coming to the properties of square numbers. The very first property is a number ending in 2, 3, 7 or 8 is never a perfect square. It means if a number is given to you and that particular number ends in 2, 3, 7 or 8 at its unit place is never a perfect square. For example, 152, 1028, 6593, etc. It means the very first number is 152. It has 2 in its unit place. 1028, it has 8 in its unit place. 6593, it has 3 in its unit place. So all these numbers are not a perfect square, or you can verify that also by taking the prime factorization of these numbers. You will come to know that these are not perfect squares. Now, second property of square number is a number ending in an odd number of zeros cannot be a perfect square. It means if the number of zeros present at the unit place or present at the end of a particular number, then if it is odd, then it will not be a perfect square. For example, 10,000, 9 lakh. So here the number of zeros are odd in number, so it is not a perfect square. Next comes square of even numbers are even. It means if I am squaring an even number, the answer will be even. For example, 2 square, that is even. So 2 square is equal to 4. Another example can be 4 square, that is equal to 16. So it is again even. So square of even numbers are even. Next property is square of odd numbers are odd. If I am squaring any odd number, that is 5 square, it will be 25, which is again an odd number. 9 square is equal to 81, which is again an odd number. So far the properties which we have learned are: first one, a number ending in 2, 3, 7 or 8 is never a perfect square. Second, a number ending in an odd number of zeros cannot be a perfect square. Third, square of even numbers are even. Fourth one is square of odd numbers are odd. I hope all these properties you have understood, because all these are very easy ones. Now, coming to fifth property. If a number has 1 or 9 in its unit place, then its square ends in 1. It means if a number has 1 or 9 at its unit place, then if I am doing the square of that particular number, I will be getting 1 at its unit place, at the answer of the units place. For example, 1 square is 1. 9 square is 81. 9 square is 81. Here 1 is definitely at the unit place. So it is this property only. If a number has 1 or 9 in its unit place, then its square ends in 1. Another example can be 11 square, that is equal to 121 again. So 1 is at its unit place. The 1 is at the unit place of the square of that particular number. Now, sixth property is if a number has 4 or 6 in its unit place, then its square ends in 6. For example, 4 square if I will be taking, it will be 16. 6 square is 36. So you must have observed that if a number has 6 or 4 in the unit place, then its square will also be having 6 at its unit place. Seventh property is if a number has 2 or 8 in its unit place, then its square ends in 4. For example, 2 square, that is 4. 8 square, that is 64. So both these squares have 4 at its unit place. Now, eighth is if a number has 3 or 7 in its unit place, then its square ends in 9. It is quite obvious. If you take 3 square, that will be 9. 7 square is 49. Both the squares have 9 at its unit place. So the properties, fifth one is, if a number has 1 or 9 in its unit place, then its square ends in 1. If a number has 4 or 6 in its unit place, then its square ends in 6. If a number has 2 or 8 in its unit place, then its square ends in 4. If a number has 3 or 7 in its unit place, then its square ends in 9. Now, coming to the ninth property, if a number has 5 in its units place, then its square ends in 5. And if you will be squaring 5, that will be 25. Definitely 5 is at the units place of the square of 5. 25 square, that is again 625. So here also 5 is at the unit place of the square of that particular number. Next is, if a number has 0 in its units place, then its square ends in 0. Obviously, if a number has 0, like 10 square you are doing, then it will be 100. Likewise, you can do the squares of the numbers having 0 at its unit place, and the squares of those particular numbers will end in 0. I hope all these properties are very much clear to you. Now, on the basis of this simple concept like squares and properties of squares, perfect squares or square numbers, I am assigning you the homework from exercise 6.1, question number 1, second part, question number 2, first part, third part, question number 3, third part in your homework notebook, and I am assigning your homework from your NCERT book only. Next, few questions are to be done in the book also, like complete question number 4, 5 and 6 in the NCERT book. In these simple questions, in these questions which are to be done in the book only, you are supposed to observe the pattern and just complete those patterns in your book. You will be able to easily do it. And question number 1, 2 and 3, all these questions are definitely based on the concepts which I have covered in this lecture. Okay, now coming to homework solutions of the lecture 3, that is previous lecture, in which I gave you the homework from chapter number 1, that is rational numbers. Now, question number 8, is 8 by 9 the multiplicative inverse of minus 1 over 8? Why or why not? Here in this question you need to tell whether 8 by 9 is the multiplicative inverse of minus 1 over 8. So first of all you should know what is multiplicative inverse. Multiplicative inverse, 1 is known as the multiplicative inverse identity, and if I am multiplying a rational number by the reciprocal of that rational number, then answer should be 1. Here in this question we will be using the same concept. For example, the concept used is the product of a rational number with its multiplicative inverse is 1. Multiplicative inverse means the reciprocal of a given rational number. So minus 1 over 8 can be written as minus 9 over 8. Now multiplying this 8 by 9 which is given in the question, we need to verify whether it is the multiplicative inverse of this minus 1 over 8. So we need to multiply this 8 by 9 by the given rational number, that will be equal to minus 1, which is not equal to 1 because we want the answer as 1. Only then it will be the multiplicative inverse. So 8 by 9 is not the multiplicative inverse of minus 1 over 8. Now next question from exercise 1.2, question number 1. Represent these numbers on the number line. This also we have discussed in the previous lecture. So let us have a look at this question now. Minus 5 over 6 lies between 0 and minus 1. So as we know that on the number line, to the left of 0 negative natural numbers are there, and to the right of 0 we need to take the positive natural numbers. So minus, as it is a negative rational number, so it will lie to the right of 0. And it will lie between 0 and minus 1. So we need to divide the line segment between 0 and minus 1 into 6 equal parts, because 6 here is the denominator, and we have discussed that the denominator indicates in how many equal parts I need to divide a particular unit, and minus 5 indicates that how many parts are to be considered. Numerator of a rational number indicates how many parts are to be considered, and denominator indicates that in how many parts I need to divide a particular unit. So on the basis of that concept, we have made a number line: 0, minus 1 over 6, minus 2 over 6, minus 3 over 6, minus 4 over 6, minus 5 over 6. and minus 6 over 6, as it is a negative rational number, so we need to move to the left hand side of 0, and 0 to minus 1, we need to make this rational number or represent this rational number like minus 5 over 6. Now next question is, find 10 rational numbers between minus 2 by 5 and 1 by 2. As we have discussed earlier, that to find n number of rational numbers, we need to make either the two rational numbers equivalent, or if they have different denominators, first of all we need to make the denominator same and multiply it by one more than the number of rational numbers required. Either of these two concepts you can use to find out the 10 rational numbers or n number of rational numbers between two given rational numbers. So we need to make the denominator same first. Either you just take the LCM or you just multiply. First rational number is minus 2 by 5, that is equal to minus 2 into 2, or over 5 into 2, that will be minus 4 over 10. Here we have multiplied both numerator and denominator by 2. Now to make the denominator 10 of the second rational number 1 by 2, I need to multiply numerator and denominator both by 5. So I will be getting minus 4 by 10 and 5 by 10 are the two rational numbers between which I need to find out required or 10 rational numbers. Now there are 9 rational numbers. If you will be writing the rational numbers between minus 4 by 10 and 5 by 10, there will be 9 rational numbers which you can easily write down, but we need 10. So again I need to multiply the numerator and denominator by the same number. Here I have multiplied minus 4 by 10 and 5 by 10 with the same number, that is 2. Numerator and denominator both should be multiplied of both the rational numbers. So after multiplication I got minus 8 by 20 and 10 over 20. So we can easily find out now 10 rational numbers between minus 2 by 5 and 1 by 2, which can be written like this. It will be minus 7 over 20, minus 6 over 20, minus 5 over 20, minus 4 over 20. Likewise, you can write 10 rational numbers between the given rational numbers. Now coming to next question number 5, find 5 rational numbers between minus 3 by 2 and 5 by 3. Here again I need to make their LCM same, denominator same. So I need to multiply minus 3 by 2 by 3, numerator and denominator both. So it will be minus 9 over 6, and 5 by 3 is to be multiplied by 2, numerator as well as denominator, it will be 10 over 6. Now we can easily find out 5 rational numbers between minus 3 by 2 and 5 by 3, that can be written like this. I hope all these questions are very much clear to you, and the chapter which we have started, that is chapter number 6, squares and square roots, all these concepts must be clear to you, and on the basis of that please do complete your homework in your homework notebook from your NCERT book. Thank you.